Managing millions of usage events requires a specialized architecture to catch and organize the raw physics of data. When switch logs and CRM records flood in by the second, SAP Convergent Invoicing serves as the engine that aligns that chaos into rigid, uniform blocks. This system ingests a massive, constant stream of disparate, rated consumption records, everything from external network charges to internal platforms and one-off CRM sales. This architecture diagram shows where convergent invoicing operates within the broader financial ecosystem. Notice how the system deliberately isolates the billing in FICA logic from the actual contract accounting ledger. Look at the incoming paths from external charging and CRM. All rated data must pass through this specific billing node before any financial posting can occur. Separating billing logic from the general ledger is a logistical requirement. It allows the system to handle the volatility of raw consumption data without risking the integrity of the accounting records. This schematic details the internal mechanics of the module: billing in contract accounts receivable and payable. The primary ingestion pathway brings data from the external charging system through the inbound interface and into the Billable Items database. From there, the data enters the billing processes block, the engine that executes the selection and grouping rules. Finally, the engine routes output to the billing document database while simultaneously generating an entry in the invoicing order queue. Our objective is to map the specific state transition pipeline that moves data sequentially through this architecture. This structure ensures CI can aggregate chaotic events into clean financial prerequisites without requiring custom code for every new product launch. The atomic unit of this pipeline is the billable item, or bit. Every bit packet carries specific structural metadata, including the source transaction ID, the quantity consumed, and the rated amount. Upon ingestion, every bit follows a rigid state transition model. Status 0, or raw, acts as a quarantine state for items requiring error correction or data enrichment before they can be processed. Once the data is complete and verified, the item moves to status 2, billable. This leads to the cardinal technical constraint. The billing engine is hard-coded to exclusively select and process bits that have achieved status 2. Enforcing status 2 acts as a firewall, trapping bad data before it pollutes downstream financial aggregations. We can ground this logic using a business scenario for a provider called Document1. Document1 generates telecommunication charges in System A and data service charges in System B. Both streams feed into the central CI hub. The customer requirement is specific. These two service streams must be aggregated into a single, usage-dependent charges line item on the invoice. To solve this, the system must identify and merge these disparate BITs automatically. This is the role of the sub-process of billing, the configuration object used to partition and route these data streams. Assigning a sub-process to specific BIT classes allows architects to apply distinct processing rules, grouping criteria, and billing frequencies to different subsets of data. Sub-processes provide the framework necessary to apply divergent aggregation logic across a complex product catalog without disrupting the core engine. This brings us to the moment the billing run executes against those status 2 BITs. Inside the billing processes node, the engine performs two functions: selection and grouping. The selection variant scans the database to pull status 2 BITs based on contract account, BIT class, and the billing timeframe. The grouping variant then applies the business rules that determine which of those selected bits can be bundled together. For Document1, the grouping variant uses the source transaction ID to bind telecom and data bits into a single billing unit. The interplay of these variants translates millions of raw consumption events into logically structured billing units. While you can run this in simulation mode for testing, an actual update run permanently alters the database. The system commits the aggregated billing unit to the database, generating a permanent billing document record. Simultaneously, the system applies a mutation to the source data. The underlying source bits transition from status 2, billable, to status 4, billed. These status 4 items are now hard-linked to the billing document ID, leaving an immutable audit trail. This simultaneous commit and status mutation ensures system consistency. A consumption record cannot be billed twice because its state is permanently locked. To understand the next stage, we must analyze the structure of the resulting billing document. The document is split into two parts, starting with the billing document header. The header stores administrative data, including the document type and the critical invoice from date. Below that, we find the billing document items. These line items store the aggregated amounts and quantities while maintaining direct references back to the original source bits. The assigned billing item type controls the downstream business meaning, ensuring the aggregated data prints as usage-dependent charges on the customer's invoice. The billing document serves as a highly structured instruction set, dictating exactly how the final invoicing process must proceed. It is important to clarify an architectural point. A billing document is not a final customer invoice. Creating a billing document does not trigger any postings to the general ledger. Returning to the architecture, we can see the final systemic handoff. The pathway exiting the database points directly to the invoicing order queue. The creation of the billing document generates an order, which serves as the mechanical trigger and structural prerequisite for the final phase. That next phase is the CI invoicing process, where the system merges various documents, executes the financial postings, and generates correspondence. By converting chaotic raw bits into structured invoicing orders without touching the ledger, the billing process fulfills its mandate, protecting the financial accounting system from the volatility of transactional data.